Hi everybody. After many failures, setting up to do just a quick internal Acme thread. This is going to be a 3/4 by 6, and part of the issue with the 3/4 by 6 is the bored hole, and then the size of the tool. There's no room for error. So in other words, it is very tight control as far as the space there, and being internal. The size of this tool head right here is as small as I could possibly find, and unfortunately I bought this one and it was advertised to do everything I needed and it works well, but it's got some small issues with it. However, the other thing I wanted to set up was go ahead and skip to the chase as far as the indicator, as opposed to trying to use the dials, because when you introduce the 14.5 degree angle, you bring in a little bit of trigonometry to that element. So let's just skip that. And this just actually go right off of the cutting head itself, or the tool post in this case. So from that one, we're going to dial this in. There is, as I said, no room for error going in. You have to have it absolutely perfectly lined up or you're going to get into a problem. So from that one, I failed at least 7 times, so I'm bearing my soul in that regard, because I think it's healthy. So from that standpoint, we're going to fire it up and we're going to get that first cut set up, and we'll go from there. I'm keeping it turning slow. I'm running at 120 RPMs, not a big deal. So this one, I just want to get the 0 set on this one. I've got it set where it goes in. Where are we going? I bumped it with my belly. Okay, so from that one, I'm going to 0 that. Now I'm going to do a couple of zeroing exercises here. This is for the carriage itself. It's not for the actual cut. But when you do the cut, you have to push the carriage back out because you can't drag the tool back across the inside of the threads. So I'm just going to double check it. It's clean. This is about 1.5 inch space, so I've got plenty of room going in. And what I'm going to do now is I'm going to go in about midway, and I'm going to bring the compound out, listening for it to scratch. Okay, right about there. Okay. And from that one, I'm going to take the cross slide, I'm going to turn it in a couple of thousandths, and then I'm going to go in. Okay, the tooling head is cut, and it's clear of the back end of the tool itself. So from that one, alright, shush. Okay, so this will be the actual cutting tool. You can see I'm getting just a little bit of movement out of that. That would probably be that clearance issue I told you about. So rather than worrying about this dial right here, I'm going to use this one to go for it. On this one, I'm going to basically back out and take like a 5/1000ths cut. Okay. From there, and I'm going to use the threading dial gauge. You can't see it clearly from there, but I'm going to go off of the 6 just for the giggles. Okay, just a scratch pass. Okay, so I'm going to take my the cross slide. I'm going to turn it in until it zeroes out. Now I know I'm right at about where I was, and I'm going to take the distance on the cross slide and go back to this 0, and before I start my next cut. So from this one, I should have pretty good clearance. I know the lathe is set on the right speed. Okay. So from that one, I'm going to take the cross slide, go back to 0 again. Okay. Then I'm going to advance the compound coming out, and I'm feeding this way because I'm cutting a left-hand thread. And I'm going to feed out. And let's go out and make that a nice round 10. Wait for it to come around again. Just gives you a basis of where you are. In the end, you have to come down into a hand fiddling fit anyway. Okay. All right. So now I'm going to take this one, turn it in. It's going to bring it back to 0. Feed in. Alright, feed back out. There's my depth of cut that I've taken so far. I'm just using the cross slide to bring it in and out. I'm going to take another 5 and wait for the 6. Okay, stop, turn in, take this one to 0, and I'm going to go back in. Just make sure I don't screw it up. Go back to 0, there's my depth of cut that I've already got. I'm going to go back into do another 5, waiting for the 6 to come around again. Okay, stop that one. I'm going to turn the cross slide in and bring this back to 0. I'm going to feed back in again. Okay, go back to 0 on the cross slide. There's my depth of cut. Okay, it's all back there again. About another 5. Okay, and again, it's really, really early in the game, but I just wanted to show you this is the way I'm doing to keep it straight, because other than that, you can get really dizzy really fast. So from that standpoint, make it simple for me. Everybody else may have it all figured out, but this is for me. I'm going to go ahead and turn it back in. 0. Go back in. Okay. One thing you don't want to hear is it scratching. Bring it back out here. Here's my depth of cut. Go about another 5. And it's going to take several times here, but I just wanted to get to the rhythm. Okay. Alright, I will bring you right back. Okay, giving you a close-up very, very early in the game. Long way to go. Okay, we talked about the depth of cut, and I showed you what we were doing up on that side. So for those that haven't seen it, change it over here. This is what I dialed out. In other words, I took the cross slide, dialed it out to bring the compound to 0, so back to the nominal 0 cut. So when I bring it back to 0 here, that is where you see depth of cut being shown. So that's what I'm doing, and now that I have the depth of cut set, I'm going to put an additional 5 on that. Okay, and from here I'm going to hit the feed lever. This is the feed nut right here on a Harrison, and I caught the 6. Yes, you can go on evens. Yes, you can go on any mark depending on what kind of it is, but you know what? I get tired of trying to remember all that, so I just go off of the same number every single time. Much like if you were going metric, you just leave the feed nut turned on or engaged. That way you would have no problem with it. So I'm going to bring that back to 0 again. Feed back in. Okay. Feed back to 0. Feed out another 5. Wait for the 6. So again, a lot of repetition. But if you get it wrong once, it's just like cutting a gear. You get it wrong once, you've made scrap. Okay, I'll bring you right back. Okay, feeding the cross slide back in, bringing the compound to 0. Feed in. You don't want to hear any scratching. All right, go back out to 0 again. That put the compound right back where it was. And the compound is at about 45 thousandths depth, so we're about halfway, thereabouts. Usually it's half times the pitch plus 10. In other words, this pitch is 6, so that's 166, so half at 80, so about 96 to 100 in that ballpark. But again, it all depends on what your screw looks like. Okay, so I'm going to feed another 5. And I'm only using 5 thousandths because that bar is extended and it is not super rigid. So that's the reason you see me doing like 5,000 increments. Yeah, it takes all day, but it doesn't get screwed up that way. Okay, 10 thousandths kit or cuts and stuff like that, that's fine. Might live, but this seems to be working just fine. And after so many failures, I'm trying to take a big safety on this. Hopefully you can see, I'm starting to make what looks a lot like an Acme thread. Not quite there yet, got a ways to go, but keeping one of the sample kits here, again, the left-hand thread, it's starting to bite, but again, this is tapered at the leading edge, so don't get excited. But there it is. Now the kicker here is, don't make a mistake. Well, after a little bit of patience, there's yours. A little bit loose. That's on me. This is not meant for anything critical. This is just going to be a couple of jam nuts. So left hand. And again, this is low grade Acme threaded rod from McMaster-Carr. I mean, it was inexpensive. It doesn't need to be anything extraordinary. But yeah, there you go. I screwed up 7 or 8 times, as I mentioned, and this method helps me keep it straight and square and keep things where they should be, because there's a lot going on, as you probably noticed. So anyway, with that being done, we're going to move on to the next project. This is all related to the shaper, and then I'll bring you up to date on that very shortly. All right, thanks for watching. Well, I did it. This was all done as far as the vertical, and right here I had this nice 1.5 inch piece of hex stainless, and I was making a nut, and I had cross drilled it 1/4 inch, and then I had punched that to an F-size drill, and then I was tapping it 5/16, and I broke the tap. Boy, did I break a tap. A nice tap. It was a very nice one, and it is super hard, I can guarantee you that, because I couldn't touch it even with my carbide drill bits. It just didn't like it. So just to give you an idea, I was trying to go all the way through. I just ran out of tap, and I was like, okay, I needed just a little bit. All the warning signs were there, and yeah, so I'm going to have to fix that mess. Everything's done. I was getting ready to be so happy to be completed with that piece of the project, but the intent on this one is big enough I can actually get my hands on this and manually crank it, or I can drop an 1.5 socket on there and then use my little impact if I need to raise it up and lower. But as you can see, it turns very, very nicely. Let me zoom you back out. Very nicely, no problems whatsoever. That's enough to grip it. If I need to make a small adjustment, I don't need to grab a wrench. It works out really well. Thrust bearings top and bottom right here, and then these are all threaded, the 3/4 by 6 Acme. I did this as a pair and then split it, and then this one down here is the much larger one that I had to fight and fight and fight. Oops, sorry. There we go. This is when I had to fight and fight to get it right. I did like 7, 8, 10 iterations of getting it 3/4 6 Acme, and finally got it right, and it fits really nicely. Everything works nice, so that table moves great. So we're moving on. So I'm gonna have to take it apart. I'm gonna have to cut this off. Luckily, I have enough left over in the bottom. Yeah, I can lower that table down just by hand. Works out really nicely. Won't take too long. And the reason I did thrust bearings here, top and bottoms, I didn't want any lifting. I obviously didn't want any dropping because the weight is going to hold it, but I didn't want any lifting as well, so it's trapped in between two thrust bearings. So I'll still have way more than enough thread left, and it's at the bottom of the table right there. So inch protruding, so when I take this and shorten it, it's going to bring it right up flush, which will be fine. The table's completely bottomed. Why would I leave threads out there to catch chips? So anyway, I had just built a little extra into it, and away we go. Okay, so I'm going to get busy and start in on that mess and fix my screw up. So it's healthy to show your screw ups. We all have them. Okay, we're going to single point thread this port right here, which is going to come through the housing on the shaper. We're going to do a 1 inch by 8. Should be good to go. Getting our final. Oh, that's good. Hold on. I didn't have the tailstock locked in. It was lifting. Okay. Now I should be happier. Oops! Alright, taking it a little slower this time. Shit!